Section 1.4 is continuity. And I've used this word already, so it's probably good that we actually talk about what it is since I've used it. What we're going to do first is I want you to think about the following real-life functions, each of which is a function of the independent variable in time. So there's the height of a falling object. So imagine something falling off of a building, a ball, or some of you might have been involved in something like an egg drop at some point. Okay. Second one is the amount of money in a person's banking account. So you might imagine getting that kind of a statement that's delivered to you online, or looking at your online where it shows the deposits and withdrawals. So this is the amount of money in a bank account. The next one is the cholesterol level of a person. Okay. You could talk equivalently of something like temperature of your body temperature or something like that too. But it's something to do with your health. The question's asking you which of these functions are continuous and why. Any thoughts?
I'm just going to guess the falling object is continuous.
Okay. You would be right. How about the, let's see, what's the next one? Bank account. What do you think? Nope, you're right. It is not continuous. So my bank account is not continuous. How about the cholesterol level?
No.
It is. You can do the cholesterol level, or in your mind you can think about body temperature. You could also think about your insulin levels, like if you have diabetes, those kinds of things, all sort of fall into this cholesterol level problem or context. All right, so here's the deal. Let me talk about the following object first, okay? The following object is a continuous because as it comes down, it's going to pass through every single height on the way down, right? It can't jump like this and go from this height down to this height. I mean, it has to pass through all the heights in order to get there. Does that make sense? Okay. Cholesterol level, same thing, as would be temperature and insulin levels, like I mentioned too. While it may be that you have a spike in your temperature, or while it may be that your cholesterol jumps up, it doesn't do it like that. It has to pass through all of the in-between values in order for it to get there, right? However, the bank account is not like that, right? Just yesterday I went to the bank and I withdrew $50 from the bank, which means that just like that, my bank account went down $50. It didn't go down a penny at a time, did it? So that makes it not continuous. It has the ability to jump up and down. In fact, that's all it does. It really does just jump up and down, right? Yours too. All right, so that's what happens with this idea of continuity. Continuity is the inability of something to have these sort of gaps in the process. It has to pass through every value for it to get to wherever it is it's going if it's continuous. Now, truly, a definition for continuous looks something like this. If we have a function and it's defined on an open interval containing the value a, then we say that it's continuous if the limit as x approaches a is equal to the function value at a. Otherwise, it's discontinuous. An intuitive way that you've probably thought about continuity before has to do with, can I draw the image without picking up my pencil? Did anybody ever tell you something like that when they talked about it intuitively? So this eliminates the ability to do things like this, right? If I have a jump in the graph, it's discontinuous, okay? And if you think about it the way that this is sort of defining it now, it should make sense from what we've been doing, because the limit as you approach from the left and the limit as you approach from the right don't match. And they don't equal the function value. I mean, one of them does. The limit from the right equals the function value because of the closed-in circle, but the limit from the left won't. But this goes one step further. In the last section, we had places where we had holes in graphs, right? When we canceled numerators and denominators. And when we did that, we talked about the fact that the function still had a limit. It's still getting close to the hole in the graph. It never actually arrives at the hole in the graph, but it gets as close as we could possibly want, right? However, this is not continuous because it doesn't actually ever get to the hole in the graph. Because if you take a look at this, this says the limit value, which exists, has to equal the function value, which doesn't, because there's a hole. Okay? So if you've got holes, if you've got asymptotes, and if you've got jumps in graphs, you have something that is not continuous. Does everybody understand what's going on with how these ideas relate?